let's do fun stuff. So, what is the main problem associated with the spinal cord? Trauma. Okay? We'll see. I'm kind of asking myself, should I put it on the board? It's just very simple. Well, some of it. So, if mechanical trauma is inflicted on upper motor neuron, patients experience basically, consequentially, two types of responses. Initially, they have hypotonia. Their muscles are not paralyzed, but they're weak. Make sense? And then, this is called spinal shock. And then they can go from hypotonia to spasticity. Okay? So their muscles become overcontracted. Right? Now, I'm not talking yet about a complete transection. Okay? What you need to understand, any kind of a destruction that's inflicted on the lower motor neuron results in the immediate paralysis. If it's first order sensory neuron, what you're going to have, it's called paresthesia, abnormal sensation. And paralysis in this way, by the way, is going to be flaccid. You understand the word flaccid? You can't contract the muscles. Now, one of the most common, and I've heard, I need to recheck this statement, but a buddy of mine, he actually has a spinal cord injury. I know a few people with a spinal cord injury. And he told me that he was very, very involved in the patient care, for people with this condition. And he told me that the leading cause of spinal cord injury in the United States is drunk diving into the pools. Even not automobile accidents. People dive into the pools, hit the bottom, break the neck. Okay? I need to check this. So transection results, if it's cervical region, so basically first 7 vertebrae, the people are considered to be quadriplegic. Thoracic to lumbar, and remember there's not much lumbar here because it ends at L1. People are considered to be paraplegic. Okay, we're good? What's the difference? So I'm going to give you 4 people that I knew. A couple of them I still know. Okay, so my first encounter with people with spinal cord injury was, we were on a backpacking trip, and the guy who had basically very, very low thoracic region, spinal cord transection, you follow me? He was on a trip of his own. He was traveling down the river in a boat. Everything was, he designed everything. It was pretty fantastic experience, just like the bravery of the guy. What happened to him? He's paralyzed below the waist. Okay? And as you go up through thoracic, you just get more and more progressive paralysis, but arms are not involved. When you get in the cervical region, and in the next unit you will see why it is so, both arms and legs get involved. Legs are gone because the transection at this level basically ensures that no signal goes to the legs. Now what about arms? The lower it is in a cervical, the more functionality of arms will be kept. So, few more examples. A couple of my buddies, one of them lives in, I believe now in North Carolina, and one of them lives in Siberia in Russia. They both got in automobile accidents, and they had transection in the lower cervical. So they are in a wheelchair, but their arms are working. So they can drive, they can move themselves around in a wheelchair. So, I mean, they're pretty mobile. Okay? Now, they have reduced functionality in the hands. You see what I'm saying? Like, they probably wouldn't be able to play piano, but they can hold utensils and shoot a pistol and write and type, stuff like that. Okay? And then through one of those folks, I met a guy who had upper cervical damage. He has some very reduced functionality in his fingers, so he can drive a completely motorized wheelchair. He can't move his arms, basically. You see what I'm getting at? So it all depends on where. Spinal cord injury is not curable by modern methods, by modern medicine. It's not curable in humans. Okay? So there was a dude that suggested he would transplant a head. No, not going to happen. That makes sense? Okay. Another couple of fun conditions. I'm going to put them, sorry, I'm going to put them in a corner. But I have a reason for it. And you will see the reason in a second. So it's going to be polio and amyotrophic lateral sclerosis. So both of them, in one form or another, they destroy the bodies of lower motor neurons, bodies of lower motor neurons in the ventral cords. Are you with me? So I will have to restrain myself from going into the long tirade about polio, but very briefly, it is a virus which is acquired via fecal-oral routes. Basically, you eat it or drink it, okay? And then it infects your gut, and in 99 people out of 100, it remains in the gut, and all you have is fever, maybe some malaise, you're fine. In 1 person out of 100, it jumps from the gut to the neuron. It's called retrograde fashion, moves to the body, to the ventral cord, and just smashes it. That makes sense? Depending on where it happened, at which level, the paralysis manifests differently. Usually it's not a complete, it's very much a weakness. Can be paresthesia though, but usually flaccid paralysis. I have an illustration of a kid in the notes with the crutches and stuff. Take FDR, who had polio. He could not walk, but he could stand. He had some very residual strength in his legs. That makes sense? The worst outcome, obviously, is when virus somehow makes it all the way to the level that supplies diaphragm, and then people lose the capacity of properly breathe. Okay. Now, polio is usually restricted to one part, the spinal cord. Just FYI, we don't have polio in the United States. We still need to vaccinate. I'm not going to go into details. Trust the science. That's it. Like, seriously, we need to do that. So go get your vaccine if you didn't. ALS, progressive deterioration of all ventral cords. That makes sense? Causes are unknown. It's a Lou Gehrig's disease. Probably genetic, probably maybe some environmental. We have no freaking idea. Usually people die pretty soon. There are exceptions. Most famous of them is Stephen Hawking, who not only lived until 70s, when he had full-blown Lou Gehrig's, he got divorced, married second time, and conceived a couple more kids. That's that. Now, before we move to spina bifida, which is an interesting topic. I want to highlight a couple of interesting things, conditions related to this neurons. Have you heard of a condition known as tetanus?
Tetanus?
Tetanus, yeah. You get tetanus shot, yes? So this is not for the exam. Tetanus is not going to be on the exam. It's caused by bacterium. Bacterium produces a toxin. And what this toxin does, it blocks the release of inhibitory neurotransmitters. So all you have is excitation and no inhibition. And all your muscles contract. Does that make sense? That's the molecular mechanism of tetanus. Now, have you heard about Botox? This is a toxin from actually related to bacteria, another bacteria that's related to the one that causes tetanus. Okay? They belong to the same genus. But botulinum toxin, it prevents the release of neurotransmitter right here. Actually, all excitatory neurotransmitters like not released. And what you have, you can't contract your muscles. That makes sense? So this is why, like, when Botox is used to relax facial muscles or to block the nerve transmission to treat pain, okay? I love to give an idea how toxic Botox is. It's rough estimate, but imagine that this bottle is filled with botulinum toxin. Okay, it's a dry. You can get it dry. So it's filled with botulinum toxin. How many people can I kill with it? With that amount of botulinum toxin.
How many people can it kill?
Mm-hmm. Can you be a little bit more specific? Well, I can give you that. All of them. It's the most poisonous compound known to humans. The amount of botulinum toxin that you can fit in this bottle is sufficient to give a lethal dose to every person in the world. All 7.5 billion people. It is insanely toxic. Okay? I mean, it's not easy to give it, but yeah, you can do it. I mean, you should. Well, okay, I'm going into the really bad ones. Okay. So, last condition that we're going to chat about, and then we're going to take a short break, is basically developmental abnormalities of the spinal cord / neural tube. There are a lot of them. I believe there are 8 or 9 on the page. Some of them have absolutely unpronounceable names. I really want you to know 5 different conditions here. So one of them, first of them, will be anencephaly. Your nervous system, your CNS of sorts, it develops from the neural tube. Are you following me? The ventral end of the tube develops into the brain. The dorsal end of the tube develops into the spinal cord and shit. When ventral end doesn't close properly, people do not form brain. Well, fetuses, they're not people. Fetuses do not form a brain. Does that make sense? Anencephaly literally means no brain. As you can imagine, this is not compatible with life. The longest the newborn was kept on life support with that condition was 2 years and 10 months. Which I don't know why. Don't ask me. Okay? It's ultimately lethal. Now another condition that also involves anencephaly is microcephaly. Really, really small head. Now, understandably, small as an adjective is a subjective criteria, right? There is a very strict clinical guidelines. You can measure their data, like you can say that measurement, that's microcephaly. That measurement, no, kid's fine, just had a little bit too small maybe. You know, the kid is smaller, so nothing wrong with that. Good. This is some intrauterine developmental problems. The most famous one was in 2015 when there was an outbreak of Zika virus in South America and people got all freaked out. Okay, it caused microcephaly. It's the permanent disability, very severe. People cannot live by themselves. They have to have someone, an adult, who would take care of them. Many of them have, all of them have cognitive disabilities. Basically, all of them have various motor disabilities, so it's really bad. Make sense so far? And then we're going to talk about a more complex developmental problem, collectively known as spina bifida. I want you to know 3 forms of it. So first one is spina bifida occulta. Let's actually parse out what these words mean. They love Latin, do they? Spina, spine. Bifida. Bifida means like two-pronged. Okay? Spine that is two-pronged. I explain what it means. Occulta means you don't see it. Occulta means secret. You following me? So what does that mean? This is your vertebral column, okay? These are your spinous processes. Are you following me? And now imagine that this, let's say this, vertebrae, this lumbar vertebrae, fails to close. So what you have is semicircular part here, but there is no closure. You see what I'm saying? Following me? There's no closure here. In spina bifida occulta, that's it. This part of the vertebra, okay, I'm going to show it on this large. Imagine that this part of vertebrae is missing. A bit more than that, but you get the drift, right? You can't see it. It doesn't even manifest. It can be completely asymptomatic. Actually, when my kids were playing football, in one of the games, kid tripped, hit his head against the ground, and got paralyzed. So they helicoptered him to the hospital. He was in a spinal shock, as it turned out later. So functionality came back together. He had spina bifida occulta in his cervical region. He was missing half of the vertebra. So he had like spinal cord just right in the open, covered by connective tissue and skin. And he was told, you should not play like any contact sport ever. Okay, I don't know if they told him that it includes chess or not. But he was lucky because they saw it. They never did x-ray before he was like 10, 11. So nobody knew because it was not an issue ever. However, there are a couple of conditions when you can clearly see that there's a problem. One is called Meningocele. The term cele refers to accumulation of fluid and bulging. That make sense? So look at this one. Not the best, but so this part is missing, right? Here in subarachnoid space, you have CSF flowing. Okay? So imagine that the CSF builds up where there is no spinous process, and your meninges, they protrude like a bubble. Does it make sense? Kind of, sort of. Not a great explainer, but So like it's building up and starts protruding like this. Like a bubble here. So you can, in children born with this syndrome, you can see, I think I have a photograph in the notes. You can see a bubble which walls are formed by meninges filled with CSF in the back. Now that immediately disrupts the flow of CSF, so all kinds of problems, hypertonias, dystonias, potentially paralysis, hydrocephaly, all kinds of problems. But that's only meninges. The real problem comes with a condition known as Meningocele. In this case, look what happens. Due to the abnormal circulation of cerebrospinal fluid, not only meninges are popping out, but the spinal cord bends and pops out. Does that make sense? So you have, no? Kinda? Got? So basically the deformation is so substantial that you can see a bubble formed by meninges, and within that bubble the spinal cord bends. This is really severe, has multiple, associated problems. So these 5 match the description with the term for the example. That's all. Others that are on the slide, I just found a really nice picture and I think it was free. So like not licensed, but okay. Questions? Okay, let's take a break.